Hello all the students. Today we are going to start a new topic, that is the partial ordering or partial order on sets. So what is partial ordering? Now many a times we use relations to order the elements of the set. Let us take the example of a dictionary. We have all the words in a dictionary. And let us now assume that we have a relation R1. Let us now take an example of a relation R1. Now the relation R1 is a set of ordered pair A and B such that A always comes before B. So this is the relation R1. It says relation R1 is a set of ordered pairs A, B such that A comes before B. Now here we have picked two arbitrary elements A and B, and we have put a condition that A will always come before B. So here you can see, if you look at this relation, you will realize that it is helping in ordering the words in the dictionary. Right, so this, what is it doing? This relation is helping us in ordering the words in the dictionary. Now let us take one more example. Suppose we have a set of all integers starting from 1, 2, 3, 4 and so on. We are considering all the integers. Now let us say we have a set relation R2. We have a relation R2 where R2 is a set of ordered pairs such that A is always less than B, right? So if we have a relation R2 on this set of integers, now what is this relation R2 saying? This relation R2 is a relation which consists of ordered pairs AB such that A is always less than B. So again, if you look at this relation, you will find that it is helping us in ordering the integers. It is helping us in ordering all the integers in such a way that the first element or the first integer is always less than the second integer. The second integer is always less than the third integer, and so on. So I can say that for all the words in the dictionary, I have a set relation R1 which is helping me in ordering the words in the dictionary. Similarly, for all the integers, I have a relation R2 which is helping me in ordering these integers in ascending order. Now if I also add an ordered pair A, A to these relations R1 and R2. Please listen carefully. Now I already have these two relations R1 and R2. R1 is a relation which is helping me in ordering the words in the dictionary, and R2 is a relation which is helping me in ordering all the integers. Now to these two relations R1 and R2, if I also add an ordered pair A, A, then how will these relations look like? R1 will be of the form now that R1 is a set of ordered pairs A and B such that either A comes before B or A is equal to B. And how will R2 look like? R2 will be of the form that R2 is a set of ordered pairs A, B such that A is either less than or equal to B. Now if we look at these two relations R1 and R2, we can see that first of all these relations are reflexive. Why are these relations reflexive? Now they have become reflexive after adding the ordered pair A comma A to both these relations. They have become reflexive. Obviously they are reflexive because now we have added the ordered pair A comma A to both these relations. So we can clearly see that both these relations have now become reflexive. The other property is that if you look at them, they are also anti-symmetric. They are anti-symmetric. In R1 you can clearly see A comes before B, but B cannot come before A. So we can have an ordered pair A comma B, but we cannot have an ordered pair B comma A, right? Similarly for R2 you can see that A is always less than B, but B can never be less than A. So hence I can say that because of this ordering, R1 and R2 are anti-symmetric also. Similarly, I can say that these two relations R1 and R2 are transitive. How are they transitive? Because if A comes before B and if B comes before C, then it is quite obvious that A would come before C. So we can have an ordered pair. So if I have an ordered pair A comma B and B comma C, so I can have an ordered pair A comma C also. Similarly for the second relation, if I see the basis of formation for the ordered pair in this relation is that we have an ordered pair A comma B such that A is always either less than or equals to B. So if I have an ordered pair AB, that means A is less than B. Then if I have an ordered pair BC, that means B is less than C. So if A is less than B and B is less than C, then it is quite obvious that A would be less than C. So that means I can also have an ordered pair AC in this case, and this is what the transitive property says, that if an ordered pair AB and BC exists, then AC must also exist. So hence I can say that the relations R1 and R2 are transitive also. So now it is high time that we understand the definition of partially ordered sets. So what is a partially ordered set, or what is partial ordering? According to the partial ordering, a relation R on a set S. Why? Because the relation is always formed on a set, right? So the relation R on a set S, denoted by S comma R, should have these three properties. Relation R on a set denoted by S comma R must have these three properties. First of all, it should be reflexive. Second, it should be antisymmetric. Third, it should be transitive. So if a relation on a set has these three properties, I can say that it is a partially ordered set. Now let us understand what these three properties mean to us. First of all, when I say reflexive, so when I say reflexive, this means that each element is related to itself. So by reflexive, I mean that each element is related to itself. Then when I say antisymmetric, it means that no two elements, or no elements for that matter, no elements precede each other. That means if one element precedes the other, then it cannot be the other way round. So this helps us in putting an ordering and forming a sequence. The third property, which is the transitive property, means that if the first element is related to the second element and the second element is related to the third element, this implies that the first and third element are also related to each other. Now, therefore, I can say what is a poset? A partially ordered set. So the poset is the short form of a partially ordered set where PO represents partially ordered and set represents set. So a partial ordering on a set is represented as partial ordering on a set is represented like this: S comma R, because a relation which will be called a partially ordered set, or which will be called a partial ordering, is based on a particular set. A relation is always formed on a set. So this relation will be called a partially ordered set, and it is based on this set. So a relation which will be reflexive, which will be antisymmetric, and which will be transitive, then it will be called a partially ordered set. And obviously a relation is based on some set. So S comma R, this is how you represent partially ordered sets or posets. It can also be written as like this symbol. Now many people confuse this symbol with infinity. This is not the infinity symbol, and you can use this symbol in place of R, which represents a relation. That means you can use R and this symbol interchangeably. So this is all about posets or partially ordered sets.